Okay, so the video for this is going through the work question on gears of simple lifting machines. So first off, let's look at the information that we have. So we've got, essentially, if we look at this diagram, first off, we know that the number of teeth on A is 16, the number of teeth on B is 72, the number of teeth on C is 18, and the number of teeth on D is 60. The diameter of the winding drum is 100. The distance from the handle to the first gear is 350, which means that if we look at the formula for velocity ratio, which will always be given to you, is VR is equal to 2R divided by D times TB over TA times TD over TC. And then the information is given to you there where your effort is essentially put in at the handle, and then the radius is the distance from where the effort is put into the center. Now if this was a motor, it would just be the effort from the motor itself, but because it's a handle, I can use this formula. If there was a motor, it would be a power transmission system, which we're going to move on to next. But then the diameter is the diameter of the winding drum. So that tells me that, so I've already done a bit here, but that tells me that my radius is equal to 350, and that my diameter is equal to 100. Now, so what I've done so far is I've just written down what I know. So I know that the number of teeth for each of the gears, I know that my load is 150, I know that the effort required is 0.015 W plus 5.5, and then my radius and my diameter. I know that my formula for mechanical advantage is load over effort. I know that the formula for effort given to me by the law of the machine is this here, which if I calculate my load, which is 150 times 9.81, that gives me 1471.5, and if I input it in here, it gives me an effort of 20.95. Then my mechanical advantage, if I use that to calculate that, it gives me 70.25. So that's a really good mechanical advantage. It means that I have to put in minimal effort to lift quite a large load. And then my efficiency is equal to my mechanical advantage over my velocity ratio. So I've already calculated my mechanical advantage, so that's done. The next thing I want to do is calculate my velocity ratio, which by using the formula here, so this is how I have to use a weight. My velocity ratio is equal to 2R over D times TB over TA times TD over TC. And when I put that into my calculator, which I'm having to use over here, I know I don't have a calculator, I'm getting one, don't worry, is equal to 105. So once I put in all of that information into my calculator, this is what I get for it. And then that gives me my efficiency of MA over VR, where I got MA is equal to 70.25 and VR is equal to 105. So if I put that information into my calculator, 70.25 divided by 105 equals, so that gives me 0.669, and if I multiply that by 100, so my efficiency is equal to 66.9%. So the last thing, this is important because the last question was whether it will overhaul or not. So if I put in my information, so I got MA equals 70.25, I got VR is equal to 105, I've got efficiency is equal to 66.9%. Because my efficiency is above 50%, I know that my machine will overhaul, meaning that if I remove the force away from it, that the winch will go back and it will start moving again. Whereas if it was below 50%, the machine would stay where it was, it wouldn't move if I removed the force, meaning that it's not as efficient as it could be. And as we said, in some of these scenarios, you want the machine to overhaul, meaning that it will stay in place once I remove a force because it is a safer operation. Okay, so that is the first worked question. I'm going to be talking next about power transmission systems and looking at the formulas involved with that, but have a go at the assignment posted on Classroom.